Hey guys, this is going to be a video on RAID levels. I'm going to explain RAID levels 0, 1, 5, 6, 10, and RAID 50. I'm just going to explain the basics here. I'm not going to actually explain advanced. I'm going to make another video on advanced, like exactly how they manage the data bit by bit and using parity bits and things like that. I'll explain how all that works and the different RAID levels, but for now I'm just going to show you the configurations and how they work. So first off, there's RAID 0, and RAID 0, first off, let me just start by saying, is RAID stands for, if you guys don't know, redundant array of independent disks. If you guys are watching this, you probably already know that, but it's basically you're taking independent drives and arranging them into what's known as a logical drive. You have a physical drive. A physical drive is your actual physical hard drive that you can touch. It's the actual drive. So, an actual hard disk that says, 500 gigs or something on it. And then a logical drive would be taking these drives, these actual physical hard drives, and arranging them into a RAID configuration in whatever RAID you might have, 0, 1, 2, or not 2, but 0, 1, 5, 6, 10, or 50. And then there's other RAID levels that are ridiculous. Even 10 and 50 are kind of out there. Usually 5, 0, 1, and 5 are most common. I'm going to explain 0 real quick. So 0 is the least redundant. In fact, it has no redundancy whatsoever. So basically what you're doing is you're taking hard drives and you're adding them. So you're taking, if you have a hard drive like, hard drive here and a hard drive here, you're adding them. So if you have, let's just say 1 terabyte and 1 terabyte, you can add them to make 2 terabytes. 2 terabytes, just like that. And you can keep going if you wanted to. And in RAID 0, the drives can be whatever size. You can have 2 terabytes, and this would make 4 terabytes. So they can be different sizes, the drives, because you're just adding them together. That's all you're doing. And basically, what it's doing is it's striping the data across. Again, I'm not going to show the advanced parts right now. I'm going to make another video explaining exactly bit by bit how the data goes into these drives, but basically it puts half the data on here and half of it on here, and half of it it stripes it. If you have 2 drives, it goes between this drive and this drive. 3 drives, it puts bits on here, 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 then it just keeps striping all the bits throughout the drives. The bad thing is if you lose any one of the drives, you're screwed. All of your data is screwed because you're striping these bits all across these drives, and it is relying on the bits off of each and every one of these drives. So, and the more hard drives you have in a RAID 0, the greater chance you have of losing a drive, and the less redundant it becomes. So, this is good for if you're storing a bunch of stuff that you don't really care about, which I don't know what that would be, but it gives you a lot more memory, but there is no redundancy whatsoever. And it does allow you to read a lot faster because instead of, if you have a hard drive, just a single hard drive, and you're recalling a data from that hard drive. So let's say you have a large disk, how do I say, demand on the disk, so you're pulling a lot of data from the disk. Well, it's easier to get data from all 3 drives at the same time to go to your computer. This is your computer, and it can recall the data from the 3 drives at the same time, which means it's 3 times faster, or however many drives you have. So it's a lot faster than recalling all the data from one drive, 1 bit at a time, versus 3 drives with 3 bits coming in at a time. It's 3 times faster. So it is faster with RAID 0. A lot of RAID levels are faster. So now we're going to go ahead and explain RAID 1. RAID 1 is simple as all it does is normally you only have 2 hard drives in RAID 1. I would imagine you could put more. I don't know why you would want to, but so let's say you have a 1 terabyte and another 1 terabyte. So you add these together and your outcome is 1 terabyte. And what it's doing is it's just copying the data to both the drives. So no matter what you write to it, it's just like having a normal hard drive, just like writing to a hard drive, except you have a second hard drive in parallel with it, and any data that's going to this hard drive is going to go to this hard drive. So it's just keeping an exact mirror image of each hard drive. So if this one fails, this one's good, or if this one fails, this one's good. If either one fails, it's good. And like I said, I think you could probably put more than 2 drives. I don't know why you would want to, because as soon as the first one fails, you just pop a new one in there, rebuild it, and it copies all the data back to the new drive, and you're good to go. So that's what RAID 1 does. And it is also, I should have told you that it is faster. Again, same thing, you have the 2 hard drives. It is slower to write to, because now you have to, it's twice as slow to write to, because you have to, when you're writing to the drives, you have your computer, then you have your hard drives. You have to write to this drive and this drive at the same time, so it's twice as slow because you have to write twice as much data. However, when you're recalling it, you can recall the data twice as fast, because you can pull it from 2 separate drives and pull the opposite bits off each drive and recall the data just twice as fast. So it is faster when you're recalling data, but slower when you're writing data. So that's RAID 1. RAID 5. This is the first redundant one where you can actually add the disks together. This is probably the most common one you'll see. It's RAID 5. Usually RAID 1 and RAID 5 are the most common RAID levels. So to make RAID 5, the minimum you can have is 3 disks. So we'll draw 3 disks. And so basically, one disk is always going to be not used. It's not used. I shouldn't say not used. They're all 3 used. But no matter what, one disk is going to be always. If you have 3 terabytes, let's just say this is a 1 terabyte, 1 terabyte, 1 terabyte. It's a terabyte. So if you have 3 terabytes of data, one of these is pretty much just, you take 1/3 of it, or any one of your drives, assuming they're all the same size, and that's just going to be used for redundancy. So if you have 3 terabytes of data, this is actually going to be used, this is only going to make 2 terabytes, it's going to equal 2 terabytes. Oops, 2 terabytes. So I'll explain how this works. But no matter what, now if you had an extra drive here, let's just say it was a 4 terabyte, you have 4 terabytes, you can keep on throwing as many hard drives as you want, but you have to have a minimum of 3 terabyte, 1 terabyte. So you would have 3 terabytes, because again, they're all the same size, and one of them is going to be pretty much just redundancy. Now in this RAID level, and I should have said this in the other one, RAID 1 as well, the drives have to be the same size. If they're not the same size, you're going to only be as good as the smaller drive. So if you had RAID 1, let's just go back to RAID 1 real quick, and you have say a 500, I'm not going to draw boxes anymore, I'll just draw the numbers, because it's getting annoying. But let's see, if you have a 500 and then you have a 1 terabyte, you're only going to be as good as the 500. Because you can't back up 1,000 gigabytes of data on a 500 gigabyte disk. So you can back up a 500 gigabytes onto a terabyte. So as soon as you hit 500 gigabytes of data, you're not going to be able to back it up anymore. So you're only as good as the smallest disk. Same scenario here in this RAID 5. You're only as good as the smallest disk. So if you have one of these is a 500, let's just say a 500 gigabyte. These are only going to be running up to 500 gigabytes of storage. As soon as these hit 500, it's done. So that's why it's kind of important that you pay attention to that. Don't think that you have an extra 500 gigabyte hard drive laying around and you'll just throw that in your 1 terabyte RAID array to get a little more memory. Actually, that's going to hurt you more, because now these 3 terabyte drives are now only going to become 500 gigabyte drives, because it only goes as high as the weakest drive. So I'm going to go back to the 3 1 terabyte drives, how I originally had it. So these are all terabyte drives, and basically what happens is it stripes the data across these drives, so you can lose any one of these drives at any given time and still have all your data. So you can lose this drive or any one of them, and these 2 drives will still have your data. Again, I'm not going to explain the exact parity bits and how it works and everything, but it is a lot slower because there's math and calculations that has to be done for this one to work. Basically, what it does is it stripes the data just like a RAID 0 does, and it stripes the data across all 3 drives, but it also makes what's called parity bits. And parity bits basically work. I'll do a quick explanation in parity bits. If you have 0, 0, 0, 1, 1, or 1, 0, and 1, 1. I know that's out of order, but let's just say. So this is what it looks like. So you have either zeros or ones, and you're striping these across the drives. So then you have a parity bit. So these are your actual bits. Here, these are your bits, and then over here is your parity bit. So you'd have a 0. Let me think. I don't know if it's. I'm trying to think. It's gonna be a 0. Yeah. So this is 0. This is 1. This is 1, and this is 0. So basically, just to make things simple, I'm not gonna explain all this right now because this is a whole damn half-hour video on its own. But what it does is it takes these parity bits, and if you have this, let's just say this is a hard drive, this is a hard drive, this is a hard drive. So these are your actual original bits, right? And it's storing, like I said, RAID 5. So you have half your bits on this drive, half your bits on this drive. But now all of a sudden you lose your drive. Whoosh, your drive crashes, right? So this hard drive is crashed, so you only have half your bits. Now normally you'd be screwed, but because you have the parity bits, you have the opposite. You have the calculations to figure out what the opposite was. So because this is a 0, it's going to know that this was a 0. And because this was a parity bit of 1, it knows that this has to be the 1. If they're the same bits, it's going to equal 0. If they're the opposite bits, like 0 and 1, it's going to equal 1. 1 and 0 is going to equal 1, and 1 and 1 is going to equal 0 on the parity bit. So if you lose this drive and it has a parity bit of 0, and the original drive has 1, you know this is going to be a parity bit of 1. So you can lose either drive, and as long as you still have your parity bits on that drive, again, since it's a 0, you know they're both the same. That's a 1, so they're opposite. 1 is going to be opposite. 0 means they're the same. So no matter what drive you lose, you're still going to have your parity bits to tell you the data that you lost on that drive. So you can lose one drive at a time, and it uses parity bits across the drive to tell which data was lost on the hard drive. So that's how you can lose any given hard drive at any given time. So I know I'm gonna make a whole video on exactly how that works, but I'm gonna go on to another video for RAID 6 and RAID 10 and RAID 50, because this has already gone to about 15 minutes. So see you guys on part 2.